Another thing you probably noticed is that some of the atoms are stuck together in groups. Atoms have the ability to connect with each other through chemical bonds. And there are two kinds of chemical bonds, as we'll get into in much greater detail later on. But for now, let's just say that one kind of chemical bond forms little groups or clumps called molecules, and the other contains charged atoms called ions. Notice all these new terms: chemical bonds, molecules, ions. These are very useful for distinguishing certain things. Here are two examples. The little pairs of atoms in chlorine gas are called molecules. These are separate groups of atoms that have the same pattern in this case, since chlorine is a pure substance. Even though the pairs of atoms are attached to each other, they're not attached to any of the other groups. So this is a separate molecule from this, a separate molecule from that, like that. Most things are made of molecules, but not all. The other option is to have atoms stuck together because they're ions. Ions are atoms with a positive or negative charge, so that attracts them to each other. And since all the positive atoms are attracted to all the negative atoms, they don't separate into molecules. They just form one big solid clump. The easy way to recognize ions is that they always alternate. First one kind of atom, then the other kind, like the green and the purple and the green and the purple, like that. That will always happen with ions. So ions are pretty rare as far as examples in everyday life. Salt is by far the most common one, but there are some other ones that we'll get into later. So we're going to spend 3 whole modules talking about molecules, and just one talking about ions. So you can kind of see that there are a lot more molecules than ions, but ions are still important, and we'll talk about them too. So it might surprise you to learn that all matter is made of atoms, but not all matter is made of molecules. Molecules are just one option for how atoms can be stuck together. When atoms of different elements join together in a specific pattern, they can form compounds. So there are 2 requirements for a substance to be a compound. First, it has to have more than one kind of atom, at least 2 different elements. So which of these substances are compounds? What about gold? No, it has only one kind of atom. So that would make it just an element. What about table salt? Yes, it has 2 elements, so that makes it a compound. What about dry ice? Also a compound. It has carbon and oxygen atoms. Notice that compounds can have either kind of chemical bond, either molecules or ions. So dry ice is molecules, salt is ions. But gold fails the test for a compound because it has only one kind of atom. The other requirement for a compound is that it has to have a pattern in the way that the atoms are arranged. All of these examples have 2 elements, but they're not all compounds. Salt is definitely a compound. It has a pattern. This is the alternating purple and green thing that we were talking about before. Carbon dioxide is also a compound. The pattern that is important here is that in each of the molecules there's a red, black, red pattern. The fact that the molecules themselves are also arranged is because it's in a crystal. If these molecules were flying all around as a gas, it would still also work as long as you have the red, black, red pattern going on. But bronze does not have a pattern. It is random. Can you see how all of those little red and green balls are just pretty much random in there? This is what happens when you have 2 metals mixed together. They just mix randomly. And so that would not be a compound. Which of the rest of our examples are compounds? Is chlorine a compound? No, it has only one kind of atom, so it's an element. What about water? It's a little bit difficult to see here, but it is a compound. It has 2 different kinds of atoms in a pattern. There's the white, red, white of a water molecule. What about diamond? No, it's just an element. It has only one kind of atom. And finally, what about hydrogen peroxide solution? This one is a little bit tricky. There are definitely 2 elements here, but is there a pattern? Well, it turns out there are 2 patterns. The molecules on the outside all have the white, red, white pattern of a water molecule, but the one in the middle is different. It has white, red, red, white. That's the hydrogen peroxide molecule. So what we really need to say is that this is a mixture of 2 compounds, because there are two different patterns. So, if we could look at all of these substances really closely, this is what we would see. We would see atoms, little tiny clumps of matter, and elements, different kinds of atoms, and the connections between the atoms, either into ions or molecules.